Well, students, it's time for another screencast with this guy who figured out how to put his face on the screencast right down there or there. I don't really know. But I'll figure that out some other time. But welcome to our third week of online school. I hope everyone is doing pretty well, and it is time to get started. So we'll do lessons. I was going to do the 4 lesson week that was supposed to be this week, but I'm going to go back down to the 3 lesson week. That seems to be working pretty well for everybody. So we'll just do a Monday, Wednesday, Friday, this one. The first one in our first picture of the day is a super pink moon. This is kind of like a fake picture of the day a little bit. This is a super moon, but not the one that you're going to see because that hasn't happened yet. So this is one that's going to, or actually has happened last month in March. So it's like a string of supermoons that are going to occur during this time period. And this one is called the pink moon because it's not going to be pink, because it's actually named after a thing called moss pink, which is a wildflower native to North America, and is going to be a supermoon because it's at the perigee, which means that it is at its closest point to Earth, and so it will look a little bit bigger, roughly about 7% or so, and it's going to be brighter about 15% or so. So this will happen on April 7th, so that's about a week before that's going to occur. So you have some time for some kind of planning out. I mean, you can do a moon party. You could go outside and howl at it if you want. You can do anything that you want. So when that actually does happen, maybe I'll look for some astrophotography, good pictures, and we'll kind of go from there. That probably will be picture of the day, though. I'm thinking next week or so. What we're doing today, it's going to be quick, so we're just going to do a couple notes on the climate, and then we'll go through and I'll tell you what your activity is for today. A nice simple one for today. Next class on Wednesday, I have planned for you a web quest, so that'll be pretty cool to go do. And time to get started. So we left off here last time. There were some questions about climate change that I got emailed, and I'll bring those up as we kind of get to the end of the section for today, and when I talk about some different things that we're doing. But we're kind of moving right on. What is climate? We did weather for a relatively long time. Weather is what is happening outside right now. Currently, a little rainy today, but a little chilly. That's pretty much about it. And climate is what is going to happen for our area in New York over a very long period of time. So climate is the general weather conditions of a large area over a long period of time. We're not talking like a month or 2 months. We're talking a span of many decades. And from that, we start to generate these things called the average decade amount of time. And we take a look at those trends and how those trends change over time. And that's because of those trends, that's how we're actually figuring out climate change is occurring as well. So climate descriptions generally include temperature and moisture, and that's roughly about it. Unlike weather, where you can start getting like more detailed, you don't really get those kind of details with climate because you're just going for the general idea of it. And so on the picture I have for you on this side is the general climates of different parts of our world. We are in this section right here. So there's New York City. We're just a tinge above that, about roughly like 200 or so miles. And we are considered this one, which is totally gone now because I moved my mouse down there, but it's called a humid continental. It means, what do you kind of think it means? We get a lot of rain kind of in New York. We get a lot of precipitation all year long, from snow during the winter, from rain during the summer. It happens. What can you do? And our temperature is a mix. Just kind of how it goes. We're going to take a look at some other ones. If you start to go up further into north, it has this like purple kind of color. We call those the Arctic or subarctic ones. Down by the equator, you're going to start seeing a lot of green, like all over into there. That's tropical wet. That you're going to find a lot of your rainforest right down in those areas. When people think rainforest, they think usually the Amazon rainforest, but there are other ones as well. You have the Congo over here in Africa, but you also have all this area over there in the Southwest Pacific. And if you're talking about like deserts, most people think like Sahara Desert, but we actually have some desert locations in the Southwest America. And you also have desert locations all the way in the South Pole, down over here, because a desert means lack of precipitation. So technically, if you have an area where it's not even snowing or raining, it will count. So for a desert, most people think of that. But for this one, for Antarctica, it snows like this much per year, so that's a tiny, tiny amount. To give you a sense of scale, that we just got more rain this weekend than they probably will get snow for the entire year. There are, depending on how you want to look at it, there are the five main factors that affect climate. There's possibly, depending on how you want to go, if you want to start talking about like plant coverage, you could work your way into like maybe like a sixth and seventh. But we're going to say mostly with these main five, and today we're just going to do our top four, and it won't really take so long because this will be a little bit of review for you. Whether it's going to go latitude, elevation, ocean, wind currents, and distance to a large body of water. Starting with our first one. And you take a look at this map. This is a heat map. You know, the hotter the color, I guess you could say, the more red, the dark red, that's going to be a higher temperature. And if you go the opposite direction and you see more blue slash like a purplish, whitish, that means colder. And you look at it pretty quick and you're like, that kind of makes sense. Cold at the tops and the bottom of the world, and right by the equator is going to be the hottest. And go ahead and take a second and look at this and try to find New York. Right there. Where are we on this temperature scale? We are down right about here-ish. New York's average temperature for the year is about 55 degrees right in our location. So it's a mix in my personal feelings on that. It's like, oh, it's 55? That means some days will be warmer, like 60s. And you're like, oh, that's not as nice as 70s. But, you know, what can you do? This is where we live. The good news about that, the colder the climate, the less dangers there are around for us. We get way less mosquitoes. We get way less ticks, even though we happen to live in a terrible area for ticks in our part of the world. But we have like a lot of these, the cold kind of keeps things back, which is really nice, which is one of the sad things we don't really want to lose if the temperature starts to kind of warm up. More dangerous things with more types of venom, usually live in the climates that are way warmer, which is something that I'm not really a big fan of. Think of like really dangerous spiders. You're not really going to find them in New York, really. You would have to go to everyone's favorite location, Australia, which they have really dangerous ones down there. So continuing on. So if you have your latitude's influence on climate. Hopefully this picture makes really good sense on that, because, you know, if you go up really high north or really low in south, it's going to be cold all year long. Even when they get direct sunlight, it's still such a high latitude, it's not really going to change too much. If you go down by the equator, it's warm all year, and then mostly it's like kind of like a forever summerous range. And right when you get to about 35 degrees to 65 degrees, that's where we live. That's a seasonal change. If you want seasons, this is really the area you have to go in. Most places, if you think about it, in our world actually do not have seasons like we have seasons. And that's how we can get those leaf tourists to kind of come up and look at our beautiful fall foliage as they go around and on charter buses and take a look at that kind of stuff. So that's why I like this graph. I like this graph even more because the more you look at it, the more strange it actually starts to appear. I'll give you a second. Take a look at this graph or / picture and be like, what's something that doesn't really start to make sense when we're talking about latitude? And I'm guessing your eyes maybe, since we were talking about New York, start to veer maybe like this way. And we start talking about, like, you know, the higher the latitude, the colder it is, lower the latitude, the warmer it is. Is that always true? And while often it is yes, there's another times where it is not. And this is what it goes on to how much climate can really be influenced. And these characteristics have some power. And to give you a sense of scale of that, here is a world map that is totally distorted. Greenland is not nearly as huge, and nor is Canada or the United States in this picture. But the latitudes actually work out quite nicely. So if you follow New York and where we are located right here, and you were to go right along that line of latitude, you go sideways and you get right into, for New York, Spain. Think of the climate of Spain for my Spanish students out there. Do you think of New York's climate, where it's kind of coldish and rainyish when you think of Spain? I'm going to guess probably not. And let's go a little bit higher. France. When you think of France, you're probably thinking Eiffel Tower, bread. They have wines and vineyards. You know, like sometimes you see like the fields of France. Do you think the same thing when you go right across and you're getting to the northern part of North Dakota? Probably not. Let's go more extreme. Think of London and what London is famous for, right? And like usually in movies, sometimes you see like it rains in London quite a bit, right? When you think of the middle of Canada, do you think rains a little bit or do you think snows a lot? You're probably thinking snows a lot. And let's talk about Greenland and Iceland. Like, look how far up Iceland is. And to show you this, I went and Googled this. I didn't make this up. This is not pre-planned. These are the exact images. I mean, if you try to Google this will probably work out for you too. I Googled Iceland pictures, and this is what shows up. All right, the top ones. This is a really famous landmark in Iceland. You have like the waterfalls. You have some nice streams, a different type of waterfall. Like you have like the green fields. And thunderstorm. Sweet. And sorry, totally distracted. You get the northern lights, and sometimes, they have a winter too. This is the same shot. So like it's all snow covered, and this would be like the summer. And like you're seeing like the ocean like a little bit in some of these pictures. And now let's take a look at Greenland pictures. The first ones that show up. Snow-capped mountains, snow. They have a whole bunch of the ocean is filling up with ice. You have a polar bear. That just kind of randomly, that made me laugh when I pulled this up. You have more snow. You have like a little iceberg over here. You have what I thought was fake, which was a whole bunch of dogs running on water, but that's actually an ice sheet. And you have that starting to melt, and that makes like a tiny thin little layer of water, so they can kind of like go right up on top of that. So Iceland, let's go down a little bit more, right? You have icebergs, right, floating right around over the place, right? Some more like dog sleds and like it looks like, I believe, huskies that are running around, right? Totally different climates. This one's way colder than Iceland. And if you go back to here, they're the same latitude, and even their pictures are dramatically different. You have the purple that's like right over here in where Greenland is. You have like their average temperature drastically different than Iceland's. And that pretty much goes into, and that there's other things that affect this besides latitude. And then, so all these, I'm going to talk about them separately, but they all start to blend together. And so another one that probably is starting to maybe throw you off is probably this one right over here, this big blue kind of area, right where there should not be any big blue area, right? And so let's go on to the next slide, which is elevation. The higher you go up in elevation, the colder it's going to get. This is a picture of like the Rockies. This is actually during the summertime. And the higher and higher you go up, in theory, air is a lot thinner. Then you eventually get colder. And then it gets the ability to precipitate, but as snow. So as you go on up, your temperature should go down. So if you take a look at this, what is located right over here, you have the Himalayas right over here. And some other high plateaus over in this location over in Asia. And you start to see this in other places, like these mountain chains. Right here along the western part of South America are the Andes Mountains. And that's why that temperature is a little bit lower as well. And then right here in America, you're starting to see some blue spots. That's where the Rocky Mountains are. So the higher the elevation, the colder it gets. And so that influences latitude. So latitude is important, but elevation also has a great impact. And there's more. The next one, ocean currents. And there's a lot of words on the slide, so I'll just kind of give you a quick read through for these. Ocean currents are movements of ocean water along the surface caused by a friction drag of wind currents. So there's a really neat part about how wind moves and how that can help the ocean move as well. More or less, we split these up into two different types. We call them warm currents, and we call them cold currents or cool currents. Warm currents carry warm water from the equator, usually to a higher latitude, either to the north or to the south. And cool currents do the opposite. They are kind of bringing cold water from the north and the south back to the equator. And when you have that ginormous spinning of warm and cold, we call it convection. And that's what this is. So this is on your reference table on page, I don't know, maybe page 4, page 5, something like that. I think page 4. And you're going to see this little chart. And so all the warm currents are usually here by the equator, and they're working their way up towards the poles. or you have the cold currents by the poles working their way up towards the equator. Either way, and these will influence temperature as well. So if you think of America and you think of the coast, you have the Atlantic coast and you have the Pacific coast. Atlantic coast over here, where we're pretty close to, and Pacific coast over here. Both have beaches, both have ocean and waves and sand. One of these coasts has the more famous beaches, and that is usually the East Coast. So when you think of like your vacationing time, if you've ever gone or heard people are kind of going around for vacation to beaches along the somewhere, they're usually going to Daytona Beach, right? Down over here, Myrtle Beach, the Outer Banks in North Carolina, right? You're having Virginia Beach, right? You will have people travel to these ones. Even people from the West Coast will fly over America to go to these beaches, to go in there, because these beaches have a whole bunch of warm currents going across them. The water is generally warmer. The California current, which is this cold current that's outlined by white, works its way down from the poles along the Pacific coast, makes that water colder than it normally would be if that current did not exist. So the currents kind of throw this off. So same spot, same latitude, the water temperature can be drastically different. This will be warmer, this will be colder. And so if you think of people going around to California beaches, and you might see this now that I kind of mentioned, like in movies or in TV shows or like in pictures if you're seeing on the news, people aren't really usually in the water. They're like walking along the beach, or if they go in the water, a lot of times they'll have like a surfer will have like a wetsuit on to try to keep themselves a little warmer because they can be pretty cold. So these currents have a pretty drastic influence on temperature, and they have for some areas even more of an impact. One of the things I mentioned when I talked about climate change last class is that different places care about it in different ways. What Europe cares about the most is this current down here goes right along the Atlantic coast of our Atlantic coast, and it's called the Gulf Stream current, and then goes across the Atlantic and then kind of washes over Europe. This is a aerial view of a heat index map of how hot the water is. Red is more hot, blue is more cold. And what happens is that this warm current goes right along the coast here, and then you have this cold current, sometimes can up here by that comes down from Canada, and warm current can go off, or maybe the cold current can kind of push a little bit. Warm and cold water do not really mix very well because they are two different temperatures, even though the same thing, that makes them two different densities. So it takes a while for them to mix. And that warm current then goes across the Atlantic and then, as I said, kind of washes over Europe. This is why, and going back a couple slides, this is why Europe is warmer than Canada. Even though they have roughly, a lot of it, the same latitude, this area is really kind of warm and this area is not, because it has that warm current. You can actually even see in this map that Gulf Stream current comes up and kind of pushes all that warm water over there, which then radiates out heat, right? And then keeps them a little warmer than they would normally be. That's why London rains and Canada snows. Same reason for the Greenland. You have cold currents kind of surrounding Greenland, keeps it colder. Some of that warm current from the Gulf Stream goes up and actually hits Iceland, which then actually makes it a little bit warmer. So Europe cares greatly about that current. And then an issue with global warming is if you start increasing the temperature of the air, the water eventually will start increasing temperature too. That means the differences between the cold current and warm currents start becoming not so drastically different, which means then the speed of the currents will actually start to slow down. So the rate of warm water going from North America up towards Europe would actually start to decrease. So you're thinking like, volume per second starts to go down. So they're getting less warm water, which means the air temperature will not be as warm, which means it can get cold. There's some worry and maybe a tiny little debate is like, could it stop? It doesn't seem right now that it will stop. I don't want to say that it can or can't because these are just predictions, but that doesn't look like that's going to happen, but it does look like it could slow down. So if it slows down, then their climate changes and they get cold. And if you think about it, there's quite a lot of number of people who live in Europe, and there's a lot of farmland that are using up there. And that, if that were to go more to a Canadian climate, would be a disaster for the people that live there. So that would become a really, really big problem. So everybody has their issues, and that happens to be one of them. France in particular is starting to note, and I brought this up a little bit, like what is France famous for? That they believe their climate is already starting to change a little bit because it's starting to get a tinge cold in some areas that where it's not really enough yet to affect people, it's starting to affect the grapes, their vineyards. Because you can't really easily transplant one vineyard from here to another spot. There's only so much land over there. And chances are that other land they're trying to move to maybe has been developed and becomes a big issue. And that's starting to change how those grapes grow, which then changes the taste, which then means that maybe people won't buy it, which then means, that economy, that section would go down. That becomes a big issue. What are they going to do? They don't know. Maybe try to make and genetically engineer some different types of grape varieties. But also when you plant these vineyards, it takes quite a number of years to actually even build up those grapes. So you would actually try to change it genetically, if possible, plant them, see if, then wait a bunch of years, then harvest, and then make, and then see if it was good. And so we're talking about like decades worth of work. And that's going to be hard for them to do. So warm currents, cold currents, big issues. That's also why if you go to New York State, and which is a little bit out of this picture, and you try to jump in the water like off of New York City, not very, very common because you have these cold currents going right down along our part of the coast, kind of keeping it a little bit colder. So currents, the third thing that infects us quite a great deal. And we'll move on. And then this one's the last one. This is like I'm going to say maybe like one of the more newer ones. It's called the large body of water's influence on climate. And it's called that because that's what I named it. But, there's lots of different names for this. But what happens is, and I'll read this too, locations near a large body of water, like an ocean or a lake, will have a more moderate climate than places that are away from a large body of water. So a climate near like the coast, like think of a city next to the coast, like Ocean City, or maybe I'm going to rough this and say like Daytona Beach, and right down in Florida. They have a more moderate climate than places more inland, away from water. And the reason for that is that a large body of water absorbs heat during the summertime. So water sinks that heat in, so it pulls it in and holds it. And then during the wintertime, it lets that heat out. So if you're a place right next to a large body of water during the summer, it's actually pulling some of that heat away from you. And then during the winter, it actually lets some of that heat towards you. So your summer is a little bit cooler and your winter is a little bit warmer, making everything a little bit nicer. So when you think of like tropical paradises, they usually have or are near the ocean. That's not a mistake. It's because the water keeps climates pretty stable, and which they really like, and that's what makes a tropical paradise really nice. So I made up some of these numbers down here. Is like if you have a coastal inland during the summer, it might be like 70 degrees. The winter might be 30 to 5. So their overall range throughout the year would be 35 degrees. If you have an inland place, it might be 80 to 20, which means the range is like 60. And these are not made up numbers. So what I went and made you this little graph over here on the left. I picked two cities that are roughly about the same latitude. So I picked San Francisco, California, and I picked Lincoln, Nebraska. A great place to go visit if you ever want to go to someplace in the middle in the Midwest. And here are their climate ranges and their mean annual temperatures of those two cities. The red is San Francisco, and Lincoln, Nebraska is the blue line, which is obviously way more extreme. So just take a second, take a look at that graph, and you'll see like y-axis has the temperature. And then the months, number 1 is January, and number 12 is December, and it goes right in order, and just in that regard. Maybe I should have labeled that when I made this, but what can you do? And you'll notice that it gets cold, right? So during the Midwest, their winters are brutally cold, way colder than it is here, right? They get way more snow than we do. Some amounts of snow that we get, we call a snow day for. They wouldn't call a snow day for. Because they just get these extreme amounts. So during the winter, it's very, very cold for Lincoln, Nebraska. And then during the springtime, it starts to warm up. And then there's a time where they're about the same temperature. And then almost immediately, right, number 5 would be May. Number 6 is June, July, August, right, September. Is that for them, that's really, really hot. So during their winters, brutally cold. And then summers, brutally hot. So why do people live there? Because it's pretty, I guess. And then eventually it goes back on and down. So they have these like huge swings in temperature ranges. San Francisco, right? Going back over their temperature range, this is the average, remember. Some days a little hotter, some days a little lower. Practically doesn't change at all. I mean, it does change, but not really to the amount that the other ones do. Now let's think of New York. We're like right here. So we're a little bit higher latitude, so we can get a little bit colder sometimes on average. About 20 degrees can happen, 25 degrees or so. And then during summer times, it can get hot. Like you can have some 85, 90 degree days, but usually not too many. And so we're like something that's like a little bit here, but we don't really get as high, and it kind of goes back down. If you go to New York City, it's like the San Francisco one, but the whole graph drops a little bit because it's such a higher latitude, and it is getting some cold currents from the ocean as well. So it all depends pretty much how far you are from a body of water. Oceans do a lot more than the Great Lakes. But if you lived right next to the Great Lakes, you would also experience this effect, just not usually to the degree that an ocean actually will do it. Does Boston Lake help and help moderate out our climate? It does. It's not as smaller than the Great Lake, but something still works. Even rivers can actually have a little bit of an effect in this as well. So that is the last slide that we're doing for today. And then this is the next part. I'm just going to talk about some of the questions that I got emailed because I was talking about climate change and I kind of brought up these things. I didn't bring up a picture. One of them was percentage of global fossil fuels used during lifetimes. And what I was talking about there is that even though we have been pulling out fossil fuels from the ground for like hundreds of years, most of it has been more recent time, and that rate picks up every single year, so it gets more and more. And so this is off by about a year or so, but it still probably would work pretty well. Is that if you're 15, in your lifetime, we have used about a little over 30% of all fossil fuels ever used. I am 34. So that's like right here, about the 35 line, that in my lifetime, we have used about 58% of all fossil fuels ever used ever. My grandmother lived to be 100. Passed away a couple of years ago, right? In her lifetime, she saw, in theory, lived through about 90% of all fossil fuel usage. This is why you're like reading more stuff about climate change and fossil fuel reduction now. And while some of the arguments of like, well, we've always been using it is true, but not at the rate that we're using it now. And that's why these numbers, they scale up pretty quickly. And these come from, so I'm not really into Twitter. I'm gonna be honest, I don't really like it at all. I debate even showing to this too, but there's some people on it. There's actually some climate scientists who actually go on there. One I really like the most, and maybe I brought him up before, is Neil Kay. He's famous probably only to me. And maybe some of us, he has 10,000 followers. He got that going for him, right? But you probably won't hear him on the news anyways. But what I really like what he does, that he does a lot of stuff with climate, and then his job is to make really neat animations about that. And so he has a whole bunch on here from like, it shows like the average change of like temperature based on latitude and how it swings right around and how you can see it actually increasing, getting hotter and hotter over the years. He makes these. He has a great one with, so like this one, like right here, talks about, I know it's probably going to be a little blurry for you, path of sun over the Europe on the solstices and equinoxes. So like what would it look like at some of these latitudes during like the summer solstice, like how much daylight they're getting versus like a spring autumn equinox. And even this one, you can see like how the shadow doesn't happen here, because the further you go up to the North Pole, during the summertime in our hemisphere, it would be full sunlight, that kind of idea. In the wintertime, opposite one over here, the sunlight kind of passes through, and it's like missing that northern pole during like our winter solstice. So he makes a whole bunch of things like that. I really like that. If you want to follow him on Twitter, if you use that, that's awesome. I'm gonna be honest, I do not. So I pick up his stuff in different ways. I just go to, he works for the Met Office, which goes, and so they kind of work on like weather and climate. It's kind of like our NOAA in the UK version, which also brings up the next thing, because I mentioned NOAA a whole bunch of times, and people were like, at least two people emailed and said, "What's NOAA?" So NOAA is our National Oceanic and Atmospheric Administration. Their whole job is to kind of look at the weather and see like how that's going to affect things. So they have some satellites they go up and work at that. They work a lot with like marine and ocean work. They have stuff with fisheries and oceans and coasts, and how marine life will affect our life on land and vice versa. They work on sanctuaries and education. They have a whole bunch of different things on here. And I figured that would go really well for our lesson is I think you should go and look at it. So your lesson for this week, which I just did, but your assignment for this week is I'm going to call it the Choose Your Own Adventure website series, which is, I was going to give you two websites. One is climate.gov, which is something else I brought up during that last class. And I would say go either to this one and click around and see what they have to say, see what they're actually doing. They come out with new news like all the time. A new species of algae named after a NOAA scientist, right? And they'll have pictures and they'll have like a little diagram about it, right? And like there's I believe the women they're talking about, and they'll have like stories what people are doing, usually all related to like the ocean in one way or another, or sometimes the atmosphere. And then they also do a lot of work with climate, and the climate.gov is a whole bunch of information about climate change and what people are doing, how they're trying to forecast that. The first article that is right here is grading the 2020 winter outlook. And what that means is that their job is to kind of, instead of trying to do like a daily forecast like 5 days in advance, which is what the National Weather Service does, they try to do like 3 months in advance. And they kind of make up these maps for like, hey, temperature outlook from December 2019 to February 2020. And they issued this in November. So about 3 months in advance. What's it going to be like? And so they give these probabilities of like, hey, warmer than average, cooler than average. Anything like right in the middle is equal chances of warm and cold. And then for this one, they go back and they take a look. How did they do? Were they good? Were they bad? And so they're trying to say in this one they did okay. That they kind of forecasted that pretty much here, down in the southern part of it's not really southern part of America, but like this swath of America, anything that's red, it will be above average. Anything that is white doesn't mean not above or below average. It means that the chances between below and above are equal. They just don't know. What it turned out to be was this. Pretty much that they were correct. Pretty much like all this was pretty much like all red, and then here was equal chances and just happened to be all red. This is their map for precipitation, where they thought it would be more, where they thought it would be less, where they thought it would be less. Anything in the middle is equal chances, which means it could go either way. And then this is what actually happened, right? So the forecasted, so more wet, dry, and then they were pretty close. Drier here, drier right there, wetter here, and then equal chances in some spots they didn't hit. So the goal is like, how are we doing kind of thing? And they make up these models, and we want to make up a new climate model. You actually don't predict it for the future. You actually go back for the past, and you see like, hey, what could we change to make this more accurate? What possibly could have happened in different parts of the world, maybe to work on that one. So there's a whole bunch of like articles in here about anything that I'm going to call suits you. From maximum amount of sea Arctic ice going on right now. What is the flooding outlook going to be, which you might be reading about in the newspaper right about now, or on the news in particular. They have a whole bunch of different blogs. They have people that do research about them for like the oceans. You can go into like case studies are always pretty neat. So like, what are people in different areas doing for climate change right now? This is North Carolina's Outer Banks. We just talked about that. They're talking about like that they get a whole bunch of heavy rain, hurricanes, tornadoes, like easterns, right? And now you have sea level rise. What are they going to do about that one? This article I remember reading like a little while ago talks about like a tribe in Northern California, and they do controlled burns. And they think if you do controlled burns, you can't get these huge wildfires areas. This one, why do we need shade? Heat islands. Goes into, this is an infrared camera. A FLIR camera. You can buy an infrared camera that attaches to your phone. It's a little expensive. It's like $150. But it actually will take shots like this, which is a pretty neat thing to do. But if you have these cities, and the cities is pretty much like, think about it, cement and pavement and stone that holds in heat, and there's not a lot of vegetation that will absorb that heat energy. So the stone absorbs and re-radiates where the plant would actually just absorb and cool it down. That's why like this area is like more purplish and this area is like more yellowish, right? That makes they call it like city heat. So cities are hotter than it is like where we are in Burn Hills, just because of the amount of like concrete and pavement that's actually there. So Albany is a couple of degrees like usually warmer than where we are up here. So they have a whole bunch of stuff in here, from maps to different data. I would say pick one of these two sites or both and just click around. Find something that you like, read about something that you never thought you'd probably read about before, find cool pictures. I mean, if you're thinking like, hey, where do I get some of these pictures of the day? Like, these pictures look pretty sweet. See what you like. You know, if you like the oceans and coasts, they have a whole bunch of stuff in here. There's a, I'm not sure what that is. Sea lion? No, it is a sea lion, right? These ginormous cargo ships, like how they're going to go. Where they're talking about trying to explore the ocean. Most of the ocean is still unexplored, 95% unexplored, which is pretty cool. Or go to the climate one and see like how these things work, like how different people are working with these climate changes. So that's my my thing for you. And then I'll have maybe a form for you to fill out that says something very simple of what did you learn, what did you like, or you know, like what did you read about. Something kind of like that. And just a sentence or two is totally fine with me. Most popular articles, a lot of people have questions about, you know, like how animals will adapt, how humans will adapt, what's going to happen when countries go, in theory, below the sea level. That's a big issue. That's all in here as well. So it's so they're pretty two great sites to kind of go through. I figured maybe now's the time to kind of go do it and then just enjoy. If you want to read more about El Ninos and La Ninas, you can see how they're actually really influencing and messing up our weather models to a massive degree, and nobody really knows what to do about those, which is pretty funny. And that's about it. So I think that's it for me today. Have a great afternoon. Enjoy reading about some cool things. And because these are all made .gov, so this is all where like a lot of your tax money is actually going to. So it's good to see how it's being spent, I think. And have a great afternoon, and see you around.